Welcome back to Engineering 252. This is a third video about the chapter 2. We're going to continue discussion about the force factor, and in this video we're going to focus on 2.7 and 2.8. And the topic of this section is about a position vector. This position vector will help us to represent a force in a direction. So the objectives of this video is how we represent a position vector in a Cartesian coordinate system, and how do we use that to represent a force vector directed along a line. To give you an example why we need to do this, you can see here is a ball, a ship, and there's a cable line connect to the ball, and we want to represent this line from the hole on the boat to this like a stop at on the bank, and it's represented as the R, which is a position vector. This position vector, if we know how we represent this position vector, we can find its unit vector. Use the idea that we show you in the previous video, and it will give us the direction because it gives you the angle of alpha, beta, and gamma, and then it can be represented as the I and J and K. And therefore, we can represent the force in the direction as the force vector. Similarly, this is another example. You have an iron that is held by 3 cables. The middle one is connect from the bottom of this point and to the hook on the top. This is the position vector R representing from the bottom to the top. If we know the R, we can represent the force in terms of the magnitude of the force and the unit vector along this line, and then we can represent the force in a 3-dimensional way. So how do we find the position vector? This is something that you learn in the math and also in the physics. In the first chapter of the Physics 130 mechanics, we tell you the position, the velocity, and the acceleration. How do we define the position? If you have a point A, you go to point B, the position from the A to B is simply equal to the coordinate of the B minus the coordinate at A. So for each one of the components, if you represent A and B in the coordinate in a Cartesian, you have X component, Y component, Z component, and for each one of the point, you find a difference using where you go to minus where you from, which is A. You can find the position vector. So if we want to find a position vector, and the direction is from A to B, we can represent this one as the RAB. The RAB is the position from A to B. We use the 2 minus the front as the position vector. So you have x of b minus x of a, and yb minus ya, zb minus za for each one of the direction in the Cartesian. And that is how we represent the position vector. Now, once you are able to find the position vector, the next thing we wanted to do is that if my force is simply represent the force in between these 2 points, how can we represent the force direction as a vector? If I know the magnitude of the force is F, we also find out the position vector RAB along the 2 points on the line. We can find a unit vector of this position and simply just use the vector itself, the RAB, divided by the magnitude of RAB. So this RAB at the bottom without blue color simply represent the magnitude of the RAB, and the top one is the vector of the position vector. You divide, you find the ratio of these two is the unit vector of that direction. With that information, we can represent the force in terms of the magnitude of the force times the direction of the force that coming from the position vector. So that is the whole idea. Let's use this example to show you how we can use the position vector to help us to express a force vector. In this example, you're given with 420 force along the cable AC. So we're looking on this one here. There's another force which is the F of B, and I suggest that you can use this example to do the same thing to find out what the F of B is. How can you represent that in terms of a vector? We want to find out the FAC force vector in a Cartesian vector form. So here is the plan. The first thing we do is to actually find the position vector RAC, which is the direction from A to C. This will help us to find a unit vector U sub AC. Once we find out U sub AC, we know the FAC is 420. We multiply this with UAC. That is our force vector AC. All right, so let's work on this one. First thing you do to find the position vector from A to C, we use the point C minus point A. Let's assume origin at the bottom here. So we have origin at this point here. Let me use different color. This is our origin. We know the position of A is on the z-axis, so there's no component in the x, there's no component in the y, and what is the component on the z? It will be 6. And this is a 6 meter. All right, what about C? The C, we have x with this much of distance, which is 2. So C is going to be 2. And what is the y? Y is 3. So y is 3 here. And what about z? Z is at the origin point, so the z is equal to 0. Right. So with this information, we can find out RAC. And the RAC is simply to be 2 minus from, that will be 2 minus 0 give you 2. 3 minus 0 give you 3. 0 minus 6 give you negative 6. And that is our RAC. And how do we find a unit vector? We know the magnitude of RAC is going to be square root of x component, y component square, z component square. Sum of them, take square root of that, you get 7 meter. So the unit vector of that is the vector itself divided by the magnitude of the vector. That give you the unit vector of that. So we can find out the unit vector is going to be this one here. Then you multiply with 420 Newton, that give you FAC. That's how you get the force vector from A to C. I suggest that you use this one as an example and go back to the problem, try to find out what the FAB is.